Hello everyone, welcome to part B of our 7.4 solving problems with quadratic equations. So we got two more examples here that we're going to be looking at, and then there'll be some textbook questions after this. So the first one, it says the function that describes the arch is, and then it gives us this function, where h of x is the height in meters of the arch above the ground at some distance x in meters from the end of the arch. So x is going to tell us from one end of the arch what distance we are from that side. Okay, and then h is just the height that we are above on this arch. Okay, so the question it asks, what is the maximum height of the arch to the nearest tenth? So what we want to do with something like this, the easiest method, we looked at several methods in our last video. There was graphing, there was using the quadratic formula, and there was factoring. And graphing is going to be the easiest if it doesn't say to do it algebraically. So we are going to graph the function and calculate the max for this. Okay, so in our calculator, we are going to type into y1 the function, which was negative 0.005061x squared plus 0.499015x. So let's get out our calculator and we're going to type that in. Okay, so turn it on, go to y equals, and then type this in. Okay, now that we have that typed in, we can go to our graph and see what we get. And for you to get the same picture as me, your window might have been different. So to get the exact same, again, this is just our standard view. If your calculator got turned off or reset, it's going to be the standard view. And to get that, it's just zoom 6. So it's just going to regraph the same picture. Okay, so again, I can't see the graph very well. It's kind of curving and then coming down. So what I want to do, I want to try to see the max. Okay, and zoom fit is always going to be a good option. That's going to be zoom 0. So it's right there. So you can click enter or click 0. Either of those will work. So I tried to refit the graph to show some more. It showed it a little bit better, but still not good. So I'm going to go zoom out, number 3. Click enter for it to zoom out. Still can't see the max, so let's zoom out once more. Zoom out, enter. Okay, and now I got a better picture. I can see where the max point is. So let's draw just a quick graph of what we just found. Okay, and from the graph, it kind of looks like it goes through the origin point through right there, but just to make sure, I'm going to go to my table. So second graph gets me to my table, and I can see it does go through the point 0 and 0. So I'm going to plot that point on my graph. So that's right there at 0 and 0. And it went through that point up and then came down. So I'm just going to draw arrows on the end of that. Okay, and another characteristic that's going to be important, it's not asking for it, but I can show you how to find this. This crossing point right here, that's an x-intercept. So to find that, we go second calc, and it's going to be option number 2, because this is at a height of 0. So you click number 2, and I'm going to scroll all the way over to that right-hand point. Okay, and then left bound, so got to go to the left, so hold to the left, click enter. Right bound, so go to the point again, and then go somewhere to the right of it, click enter, and then it's going to guess in between these 2 points once I click enter where the x-intercept is. Okay, and I get 98.6 about, so let's write that down. Okay, now what the question actually asked for was we wanted to find the maximum height, and the maximum height is going to be right here. So let's just plot that point. And then in our calculator to find that, we got to go second trace, that gets us to the calculate, and then we want to find the max, so that's number 4. Takes us back to our graph, so scroll all the way to the vertex, the max point, And then left bound again, go to the left, click enter. Right bound, so go back to the max point, and then go somewhere to the right. Just make sure you're for sure to the right of it. Click enter, and then again between these 2 points, it's going to try to find the max. So one more time to guess. Okay, so we got this 49.3 for x, and for the y it was about 12.3. So let's write that down. Okay, so to answer the question, it said, what is the maximum height of the arch to the nearest tenth? I can see the max height, it's right there. That was h, and this was x. So the max height is 12.3 meters. Okay, so the next one here, it says, assume that a football pass went a distance of 32 meters. So it's going to go from one person to another person. That distance is 32 meters. And it was 10 meters higher than the passer and the receiver at its highest point. So if the one person's height is here and the other person's height is here and they're the same height, that pass is going to go up 10 meters above them. So it's going to go through the air 10 meters above their heads. Okay, and then it says assume the passer and the receiver are both 1.8 meters tall, so they're the same height. So part A, sketch a parabola to represent the situation and label the information given. So let's sketch a simple little graph. And on the graph, we're also going to have our people standing there just so that it makes the question a little bit easier to interpret. So I put my distance on the horizontal axis. It's measured in meters. And then on my vertical axis is going to be my height, and that's also measured in meters. And then I'm going to put my one person here. He is standing kind of right at the y-axis. I'm just going to move him down a little bit. Okay, and then I'm going to put the person that he's passing to over here. Okay, and we knew from the information given to us that they were a distance of 32 meters apart. So from one guy to the other guy all the way over, that is 32 meters. Okay, so all the way to here, 32 meters. Okay, so I know halfway between that, it's going to be 16 meters. That's going to be an important point. And this guy, he's at the 0 meter mark. Okay, it also told us that the pass was 10 meters higher than their heads. So I'm going to draw a dashed line going from one person's head to the other. And then the ball went 10 meters higher than that. So let's say the ball went as high as that. So it got past, reached that max point, and then came down to the other guy. Okay, so this distance in here, this is 10 meters. And then the last piece of information they told us was that both of them are 1.8 meters tall. So this height, this is 1.8 meters. Okay, so if this is 1.8 and then this is 10, the total distance is just going to be 1.8 meters plus 10 meters. So this total height is up at 11.8 meters. So that gives us this point. Okay, it is 16 over and 11.8 up. Okay, so now we have sketched this parabola and we've got the situation all labeled with all the information. Again, this was 32 meters apart, half of that is 16. This guy, well, both of them were 1.8, but they threw the pass 10 meters higher than that, so it's 1.8 meters plus 10 meters. That gets me 11.8 meters. Okay, so part A is finished. Moving to part B, it says, how high was the football to the nearest tenth when it was 25 meters from the thrower? Okay, so on our graph, we want to see how high it is. If it was 25 meters from the thrower, we want to see what that height is right there. Okay, and to do that, we are going to have to solve this algebraically because I can't just try to guess what that is. I know it's going to have to be more than the height of them, and I know it's going to have to be less than the max point. Okay, so in this question, we know one important thing, and that's going to determine what we're going to want to use. We know what the vertex is. Okay, so if we know the vertex, therefore, we are going to want to use vertex form. Okay, so writing out vertex form, it is a times x minus h all squared plus k. And then I'm just going to change the h and the k into different colors here so we can distinguish them. Okay, now that h and that k, that was the vertex. So I knew the vertex. The vertex was the point right here. That was 16 and 11.8. So I'm going to put those two numbers down here. So I'm just going to write 16 and 11.8, and it goes h and k. So we're going to plug those in. So I got y equals a times x minus, and then h was 16, plus, and k is 11.8. Okay, so I have everything filled in except I don't know what that a value is. We need to find a. So to find a, we're going to have to use a point. Okay, now it doesn't matter what point, just as long as I have a point. So looking up on our graph, there are a couple points that we could know. There's this point on the parabola, and there's also this point. Both of those I know. The first one here is at 0 and 1.8, and the second point is 32 over and 1.8 up. Okay, now of those two, this one is a lot simpler. There's smaller numbers compared to this one, so I want to use this one. You could use this one, it's just going to be more difficult with this. Okay, so we're going to use the point 0 and 1.8. Okay, and in that point, x is 0 and y is 1.8. So those are going to switch out over here, x and the y. So y now changes to 1.8. A we don't know. X is 0. And then write everything else out. Okay, and then from this point, we're just going to start to simplify and solve for that a there. So 1.8 can stay how it is. Got a times 0 minus 16 is just negative 16. And then negative 16 squared is going to give me 256. So I got 256 times a plus 11.8. Okay, so let's start isolating that a. So we got to get rid of this, and we got to get rid of this. Okay, first thing we want to get rid of is this 11.8. So subtract 11.8 from both sides. It's going to cancel there. And then 1.8 subtract 11.8 is just going to give us negative 10. Then on the other side, 256 times a is just 256a. And then we'll get rid of that 256, so divide by 256, divide by 256. The 256's are going to cancel. And so I just have a is equal to negative 10 over 256. And then simplifying this fraction, I can divide the top by 2 and the bottom by 2. Okay, and then that is going to give us a is equal to negative 5 over 128. Okay, now that I know what a is, I'm going to have to take a and I'm going to have to put it back where we were missing it. So it's missing right there. So we're going to take it and put it back there. So I'm just going to write out what we had in this line here first. Okay, and now we can put the a and it's going to go right there. So I got y equals negative 5 over 128. x minus 16 squared plus 11.8. Okay, so now I know what the function of this parabola that we had up here is. Okay, and that's important because once you have the function, you're able to find any point on the parabola. Okay, you can use it to calculate and find any point, just like what we did on this first one. We were given the function, and then I was able to find a point. I could find the max height. Okay, so now that we got that function, we're going to use it and find the point. So we're going to use our calculator, and we're going to enter this into y1. Okay, so let's pull out our calculator. We're going to go to y equals. Okay, and then clear what we had from before, and then start to type this in. Okay, just make sure when you type this in, you got both of your brackets here. If you don't have the brackets, you're not going to get the right thing. Okay, so let's click graph, and let's see what we get. Okay, so I got that right there. Now, what I'm going to do is I'm going to click zoom 6. You can click zoom 6 too, just so we get the exact same picture. Okay, so it's zoomed in quite a bit. I can't see all of it. I'm going to zoom out here and see if I get a better picture. So zoom 3, enter. Okay, and now I got a picture of the whole parabola, or at least the part that I want to see. And then we wanted to find, again, the question said when it was 25 meters from the thrower. So we're going to be over 25 meters. Just like in our picture up here, over 25 meters, I'm going to be up. We want to find what that height is right there. Okay, so in our calculator, we want to find when x has moved over to 25. So we're going to go second, trace, and then we want to find a value. So we're going to click enter or click number 1. And we want to find when x is 25. That's going to give us out the y value. Okay, and it happens to be 8.6 meters. Okay, and then just to double check that, we said we knew it had to be more than 1.8 because it's higher than that. That's how tall we are. And we knew it also had to be less than the max height, which was 11.8. Okay, so 8.6, that would make sense. So let's write that down below here. And I'm also just going to write out our steps here first. So our buttons were these. We click second, then we click trace, then we click number 1, it was for a value, and then we did when x was equal to 25. Okay, so each of those was just a button that we put in, and it gave out our answer. Y was equal to 8.6359. Okay, and then the question, it asked for it in the nearest tenth, so we got a round. So we're going to get 8 point, want that one. 3 is not going to round it up, so we get 8.6, and our units were meters. Okay, so that was our last example. I'm just going to write out our homework questions here. So they are on page 430, and we just have question number 5 to do.